I want you to take a moment and pause this recording so you can attempt this problem before we talk through it. So it says that, and this comes from the first question of paper 1 from the May 2016 examinations. It says combustion of ethanol takes place according to the following unbalanced equation. And so we've got ethanol, a few things to remember. So ethanol is an alcohol, that's what the OL stands for. Eth stands for 2 carbons, and so this is our ethanol. And it says combustion, and we want to remember that combustion always reacts some hydrocarbon with oxygen to form carbon dioxide and water. Now in this problem it gives it to us, but quite often you'll have to remember that one without having it given to you. This one's just asking for us to balance it though. So we can do it the long way if you are not confident in looking at it and identifying what it is right away. And so when we're doing it with the long way, we do a little bit of accounting. We've got carbons, hydrogens, and oxygens on both sides. We want to see how many of each we have. So on this side we have 2 carbons there. We've got 5 hydrogens plus the one that's there, so that's 6 hydrogens. And then the oxygen, we have 1 that's there, 2 that's there, so 3 total. On the product side, remember the product side's on the right side, we have reactants and they form products. We've got 1 carbon, we've got 2 hydrogens, and then we've got 2 plus 1 oxygens, so 3. The first thing that we want to tackle are any metals. We don't have any metals here though. Then we want to get any ionic compounds or any ions, and we don't have any ions, so we're going to not worry about that. We could deal with nitrogen next, but there's none of those as either, so we're going to deal with the carbon first. And we've got the 2 versus the 1, so what makes sense to try is to do a 2 in front of the carbon dioxide. So I now have 2 times 1, that's 2 carbons, and I have 2 times 2, 4, plus the 1 oxygen that's there for a total of 5 oxygens. Now we can deal with the hydrogens. We've got 5 plus 1, that was the 6. Here I just have 2, but easy enough, we put a 3 out front as the coefficient. I now have 3 moles of water. 3 times 2 is 6, but I also have changed my oxygens again. So I have 2 times 2, that's 4, plus 3 more, that's 7. So we're dealing with 7 oxygens now. We want to get our oxygens balanced because right now we've got carbons and hydrogens all balanced. My oxygens I wanted to save for last because this O2 makes it a little more versatile to deal with. So we want to deal with that last. And we see we're looking for 7. I've got this one here that's on its own, and I don't want to change that one. I don't want to change this coefficient because that's going to change all of my carbons and hydrogens, and I'm going to have to go back to fixing those. I don't want to do that. So I'm going to have 7 that I'm looking for, but I've got the 1 there, so really I'm looking for this one to be 6. And easy enough, 6 can be the product of 2 times 3. So if I put a 3 there, I've got 6 plus the 1, that makes 7. And now I've got my oxygens balanced as well. So it says the mole ratio of ethanol, looking at that one first, to oxygen. There's nothing written there, which means it's a 1. So it's 1, 2, 3. And so our answer is C. Now a common problem that you'll see on an IB exam would be similar to this, but it would ask you for the total sum of the coefficients. And that's one that a lot of people end up getting wrong because they would see the 3 here, the 2 here, the 3 here, and they would be like, oh yeah, it's 8. But oh no, it's not. It's actually, it's actually with this 1 here as well, so it's 9. So that would be the sum of the coefficients. And again, that's a common problem that you're going to see that's going to have something where you're like, oh yeah, even though I don't write it, it's a 1. So you don't want to forget that.